Our next speaker is Hunter Inman, KK7NQN. He came out of nowhere at me and to describe his really cool project, which he will tell you about. I won't steal his thunder, but man, talk about a new tech ham. And he's diving in with both feet. And what struck me, and as I wrote in Zero Retries, he's bridging the old repeater paradigms of talking with voice with the new paradigm of integration with text and notifications now. So it's really cool project, and I can't wait to have him talk about it.
Hello, everyone. I'm Hunter, KK7NQN with the KK7NQN Transcriber project, or the TSN now that I've called it. So I got my ham radio license a couple of years ago, and I am very much one of these new tech hams. I got my radio license purely because I wanted to play with a cooler walkie-talkie, I guess. And with that, I did basically nothing with it for almost a year. And then I started looking at some of the cooler technologies, the cooler control side. And what attracted me was what they do with repeater control, with like auto ID and stuff like that. And that control side, the controlling things, is what attracts me to radio still, is being able to control stuff with something electronic. And my experience in radio was limited, so I couldn't go into like digital data modes or anything like that. So I stuck where it was cheap and easy and available. VHF voice. That's what I started playing with. So I built a repeater. I built a full duplex repeater just to see if I could. That's my whole thing in radio and stuff general. I just wanted to see if I could do it, which that was a cool learning curve. But the problem I ran into, which is what a lot of people in repeaters run into, it became exactly just another dead silent local repeater. Nobody talking on the repeater, nobody doing anything. And I looked at that and I seen it happen all around. There's several local repeaters that I can hear, and they're always just dead silent. Maybe once a week you have a net or something run. And that's about all you get. You throw your call sign out every so often, get nothing back. So the idea I had was, what could we do to take that voice call? You throw your call sign out, hoping somebody hears you at that second. What could we do to change that? And my idea was I could do it with code. Like, what if I just had an autoresponder? And I wasn't sure how to do that, but I knew to run code based off of speech, I needed to do one thing. Step one of that is to transcribe. I needed the text out of the audio to process it. So I started writing code, started writing Python. I had to learn Python at the same time. I knew no coding. I knew a little bit of Java starting this. So I was learning Python while doing this at the same time. And a lot of it was Google AI, ChatGPT, and all of it, just trying to learn basically everything. I'm learning the radio side, I'm learning how to write code, and I'm learning how to do this whole project that I'm doing. And what I ended up with was I used my repeater and my SDR as an interface. That was basically the pipeline of audio in. And the way I seen it was this audio and this audio pipeline into the repeater was basically my data stream. As you think about it, a conversation like between two people, it contains a lot of data. You are transmitting data to the person in front of you and back. And one of the cool things I thought about doing, because ham radio has identifiers, your call sign's your identifier. I wanted to pull this out of that data stream. I knew it should be possible because we as people do that. We hear a call sign, we pull it, write it out. So I started looking at open technologies because obviously I'm not going to write my own transcription system. And so I started looking at open APIs. Well, what is some open source software I can use to assist this and assist amateur radio in general? And what I ended up with was two things, an SDR input and a repeater input into Whisper AI, which does exactly what I need it to do. It takes audio and makes it into text. And doing that is a good first step. The problem that I ran into, which was made the project a whole lot bigger than I thought, was when you transcribe just audio to text, speech is not perfect and computers like to be perfect. So what you get is malformed, weird text strings. But with a little bit of post-processing, like what we do on basically anything in digital communications, you can post-process your malformed data stream and kind of bring it back enough. And this allows cool things. So like now, you go back to the quiet repeater problem. You throw your call sign out, and if there's nobody listening, nobody hears you. Now, when you throw your call sign out, the repeater heard you. And the repeater is automatically logging what it heard. So now you throw your call sign out, the repeater hears you, you're on the log. That's step one of what I wanted to do. Step two was the historical value of the data. Conversations don't have to end. Like when you're having a conversation with somebody on a given day, that conversation doesn't have to end when you both walk away for that day. You or anyone else can now go back and look at what was said, what was talked about, what was discussed, who were the participants, and continue it. And this also ties into nets and clubs. Imagine being a club and being able to look back at what your nets not only discussed, but how long they discussed something, what they were discussing, who was involved, and get that at a glance. Just a simple click, couple filters, and there's all of the data. There's no trying to capture this live. There's no writing it down. It is there, it's instant, and the technology is there and advancing rapidly. So using the power of AI, basically, instead of me having to hard code and trying to guess and stuff, I can give AI the conversation and it can produce what it thinks the context is. And that allows basically categorization. It allows me to categorize what I think was happening, why I think it was happening. And I've started doing this. Like if you go to KK7NQN.net, you'll see a tab called Nets. And that has been a completely auto-detected thing. The repeater has picked up on the pattern that, for instance, Puget Sound Repeater Group every day at 9 a.m., noon, and 9 p.m., they have a net. It has been able to determine that is a structured net. It happens on a pattern. So we will treat this as formal communication. We can put that in the log safely. It happens at the same time every day. And same thing with non-formal communications. When it hasn't determined a pattern, there's no pattern to like when you and another operator have a random QSO on the air. It does know that, but UID, so it knows who. So this is where I try to break into the new tech ham thing, like I am. I just got a tech class license. I just want to talk to people every once in a while and do cool stuff for radio. My idea to help the engagement was to gamify it. How do we make it to where there's more interest to it other than just talk to people? If I wanted to just talk to people, I'd get on a Discord chat or Messenger chat and talk to several hundred people, and there's no limitations of propagation and all that stuff. But if you take the radio aspect, the propagation and using a radio and the signals and the RF side, and turn that into the challenge, and then you take that record that we just made and put it on stats. Now you can make this like a game. Who has the most QSOs? who's talked the most, who's made the most contacts. And the cool thing about doing it with the transcription service, it's automatic. So like my generation that has an attention span of about 6 seconds doesn't have to write it down. And frankly, if I wrote it down, I couldn't read it in 5 minutes anyways. But it has that automation. It does it for me. All I have to do is talk to people. And while I'm talking to people, the system sees it, the system does it. Now I have a page. I can give them my call sign page of this project, hand it to my buddies, be like, I've gotten 45 QSOs this month. What have you gotten? And that's the aspect I see. Bringing ham radio to the newer generation, this gamification, the excitement, the stat sharing, the data sharing, all of it. Because the newer generation is all about the data, the stats, the competition, but it has to be fast. The new generation, like I said, the attention span is not very long. We've been accustomed to short format stuff. You scroll through Facebook Shorts, you scroll through TikToks. That is what the newer generation is for. Couple second attention spans. So if we can take that short attention span to where they're not having to log stuff, they're not having to write it down, then put it into a digital system where it does it automatically in a competition, now we've made a game. That drives a lot. But at the same time, that side is feeding the other side. The older hams that just want to talk to each other on their radio, that they just want to have their nets, they want to talk on their radios, they want to do the propagation stuff. All of that, they're involved in the system too. But it ties back into data and accessibility, automated logging, and club data, personal data, and other things that I don't really think about that often. Think about accessibility. Think about somebody who has a hearing impairment. If you have a fast enough server, say a club runs a server that's running a relatively decent hardware, they can run ATSN on a fast server and give live transcripts, or almost live, very, very few milliseconds of latency. That means now we can have hearing impaired hams participate in active ham radio QSOs. And another thing with AI, we can go the other way too. Instead of going speech to text, we can go text to speech. So even if this hearing impaired ham can't speak correctly, they can still speak indirectly through speech to text. It becomes a bidirectional system, or could be really easily. It hasn't yet. But AI is rapidly improving, rapidly progressing. And one of the things I am doing now, and one of the things I ran into when I started in ham radio, is my generation, our first resource for anything is Google and AI for information. When you Google ham radio, when you ask AI about ham radio, you will get textbook excerpts of how ham radio is supposed to work, these perfect conversations, perfect QSOs. And really what it did, it made me have severe mic fright. I mean, it took me 6 months before I clicked the push the talk button. But one of the things with the TSN project now, we have actual history of actual QSOs that happened, nets that happened, conversations that happened, everything real. So now we have record of what it is like to get on the radio and actually talk to other ham radio operators. And this has piqued interest of some really big players in the game that distribute this information about the ham radio, amateur radio space. Google, OpenAI, and Anthropic have all started using this, my central database, as AI training. This is going into that AI progression now. AI will now be able to communicate what ham radio actually is and give insight what ham radio is actually like to talk to people on the air. And frankly, it's not that military strict textbook like you have to be perfect like I thought it was going in because that's the information I got. it shows the real hobby. And at the same time, that gamification comes back. They want to get their license because it's a challenge. They want to compete with their buddies because it's a challenge. The data's there. We have the back end now. And the way I built this system, the TSN system, is entirely designed so that other people, the community, can take it and build on it. I didn't want to make something that is mine. I didn't want to make something that was like, hey, I can take ham radio and make it text, put it on a webpage. I'm cool. No, what I wanted to do, I wanted to make it a resource. So when I started writing this, the idea was as versatile as possible. So every step of what this system does is its own individual module that you can run individually or together. It doesn't care where it gets its data from. It just does its job. So you can run full stack, half stack, or just individual steps. And what that does is instead of interfacing directly with a repeater like I do, you can interface with an SDR. Your software-defined radio could be your input, and then your output could be wherever. It is just outputting data with an input. Or All-Star could be your input. Or let's say instead of outputting to just a web page, you want to output to a software that actually does something deeper. That could be your club or whatever. And then another thing of how it's written, it's meant to be a library. So let's say you don't want to run your own whole backend. You don't have to. The data that my system does is there. There's the API. You just go to the API. You pull what data you want. You do what you want with it. And that goes into farther down to is it is so modular that the main central hub system, the club or whatever, doesn't have to run the system. A third party can run the system on an SDR or an All-Star node and just have the club connect to them or just be in RF range of the club. It's not an integrated part of whatever your data input stream is. And your data input stream doesn't have to be radio. It can be any audio source. One of the things I did when I did the TSN is the TSN is standalone. It is a simple audio in, transcription out with the call sign extraction on off. So it doesn't care where the data comes from. It doesn't care where the data is going. It does its job. So basically, if you picture it, now we have AI learning about ham radio, amateur radio. We have clubs that can immediately track data. We have people that can immediately view their own stats, data, time spent, all that. And we have incoming people that can see real world applications. What are people doing on ham radio? Why would I want to get a radio license? Why would I want to be involved in this? Stuff like that can be directly answered with real world stuff that is happening, other than just like watching YouTube videos or reading the textbooks. Like I said, my generation, we're going to Google it and we're going to ask ChatGPT. And those answers immediately make people like me not interested. Because it just seems, one, frankly, very outdated and old school. Like I said, if I wanted to just talk to people on a radio or a walkie-talkie or whatever, I would hop on a Discord chat or a Messenger chat. So taking that concept, then you link it into All-Star. Like my main system, the one thing I want to do with the main central system, the TSN system that I run on KK7NQN.net, it links into the Dewdrop and All-Star network, which is an international network. So now the system is showing traffic internationally all around the world. We got Worldwide Friendship Net, TransCanada Net, PSRG, all that being transcribed, logged. And all that data is now available. People can see ham radio is not dead. It's not dying, it's not fading out. There is activity there. There's activity all over the place. And now we have the data to show it. So when a new ham is looking at getting their ham radio license or has their ham radio license and trying to contact people, when they Google it, when they ask AI, as we build systems like this, they can see the real data, the real usage of why do you want your ham radio license? And the cool thing is it progresses from that too. It's not just voice. And like I said, it's data. It doesn't care what the audio is. Its only job is to capture data. And doing so, it is a simple data in, data out. The data in, data out. So basically, whatever the radio hears is processed with AI. And the cool thing about AI is since it's adaptive, it can learn what the input is. So if you're not putting in speech and you're putting in some sort of other data, your AI, which you run locally, can be tailored specifically for whatever it is. So say you want to make your own data stream across radio. You make your own mode, entirely possible. Now the back end for taking that data in and processing it and storing it is there and done. And like I said, you don't have to do it yourself. It's modular. It can be on anything. It can be on anywhere. Imagine if this became a standard, like the club you are a member of, the clubs around start running transcription on nets. Now, when you're convincing people to join, you can do so with transcripts and real life things. And you don't have to monitor nets as well. You can sit there and do whatever you're doing. And this is where a feature Steve actually brought up in his article of getting notified when something interesting happens. So instead of having to actively monitor the radio for hours on end, now what you have, the system knows what's going on, what all the data is, and it has context. So you can filter that data. What do you find interesting? What's a context you find interesting? What are keywords that might mark something that's interesting to you? What's your call sign? Stuff like that. And now when that data goes by, it can tell you that the data went by. You don't have to actively do the filtering anymore. You can be out doing whatever and your phone dings and look, oh, they're talking about something I find cool on the local repeater. Now you can grab your radio and actively participate in the conversation. You can join in, do what you find interesting without spending hours a day on the radio. Again, comes back to my generation's attention span, not long enough to sit there on the radio and just monitor. And another thing I hinted at earlier on in the talk is conversations can continue. So now you've been notified that an interesting topic went by or your call sign was mentioned, they're talking about you. You jump into that conversation, you have some QSOs back and forth, but you got plans, you're going to go do something. You can't be on the radio, whatever. You can come back to that. Just think 2 days later, you read the transcripts, where were you at in the conversation, same with other people. And you can continue that conversation. Everyone can. Even people that were not part of the original conversation can look and see what was said. And same thing other way around. If you were not involved in a conversation, but you've seen that it happened, you found it interesting, even after that conversation has stopped, it can continue right where it left off with different people just by skimming the transcripts or getting a notification. It doesn't directly have to involve you. It's just the data of the conversation. And I think that's all I really have. Do I have any questions? Yes.
Stand by for the microphone so the folks on the streaming can hear it.
Steve. How does your text or speech to text work with like DMR and other digital modes that are basically kind of muddy?
So with digital modes directly, I haven't actually tested it because I don't have the capability, I don't have the knowledge to do it. But in theory, it should, as long as you tell it what to look for, it should be able to process it.
Okay.
Yeah.
And cheap question, does it decode repeater IDs and Morse?
What was that?
Does it decode Morse repeater IDs?
Yes, it can.
Oh, cool.
That is something I did do. It's not perfect, but it does do it. Or attempts to.
One question that occurred to me that I didn't understand. How did you teach it to recognize a call sign instead of just randomly transcribing? That's a unique piece of data.
Yeah, so call signs were interesting because there's two ways you do call signs. You say your call sign, like KK7NQN, or you do it phonetically, Kilo Kilo 7, November, Quebec, November. Computers don't naturally think like that. The transcription I get out is raw letters or raw phonetics. So my post-processing that I do, I run it through what's called the corrections database. So, and what that is a regex, and it checks the text for things that I've told it to look for. So like if it sees kilo in the text, it's gonna remove that and replace it with a capital K. So then we move on down the line there. Once we've done that, we've corrected our phonetics, we've corrected some mishears that I've seen AI do because AI will hear random stuff and transcribe it wrong. Once those happen, to actually get the call sign, we remove all spaces and punctuation and smash it. So now we have a one big long string of just capital letters. And call signs have patterns. So you look for the prefix and the suffix. And when you find one that looks correct, you pull it in what is a call sign. And then QRZ has an API.
Oh,
So now I just bounce that off QRZ, and if it comes back valid, it goes in the database. It is a call sign. We've verified it is a call sign.
how do you correct for the creative invention of phonetics?
So that's why I use a corrections database rather than just a fixed phonetics list. When a specific creative phonetic is heard, I can just one click add it to the database, and now it knows that when it hears that to correct it. So like for K instead of kilo, they say king. That's in the corrections database. So when it sees king, capital K, it's still going to correct that to a capital K because I have told it that that happens sometimes.
Your thoroughness just amazes me, and you work through these things, and this is the first as far as I know. So kudos.
Yeah.
Other questions? Hang on. Oh boy, hot topic today.
Sorry, see, I grabbed a mic for this is KM4SXP Samantha. So I thought it was really interesting your talk, especially about the gamification. And something that kind of struck me as cool to add would be the ability to determine a distance when you make a contact, the distance between them. That would be cool for, first of all, the gamification piece, but also learning about propagation. And then the question comes, well, how would we do that? And I don't know if there's an answer for that, really, and especially the way things are traditionally done. But at least for me, from my side of ham radio, where the propagation and the electronic part of things is really my interest. It's something I'd be interested in exploring and figuring out how it could be done. So
something cool that I have been experimenting with. I don't have that wide of an area that I've experimented on this yet, but one of the things why the SDR module exists is since I'm taking audio in, one of the things it can add into the data which is available in the API, is the signal to noise ratio. So how much voice it heard versus how much noise it heard. So you can go set up an SDR somewhere, make a transmission from somewhere else, and then live feed it to your phone and see what your signal is to that area. So now imagine you had a network of those listening stations. Now you can test your propagation and see how it's traveling. Yeah.
Hey, Craig, N7RWB. So this is a really interesting project. It might tie into a thing I'm kind of thinking about for making a dashboard for monitoring complete hand bands like 2 meters. But I'm wondering, do you have any statistics for um, the for actually identifying the presence of a call sign? Do you know how many false positives and false negatives you typically see? And then once there's a call sign there, how accurate is it typically in the stuff you've seen?
So I don't have a direct statistic on that. And the issue that I run into a lot is that the false positives that I pick up on aren't necessarily false positives. It is in a sense, as that wasn't the call sign that was said, but it isn't in the fact that it is an actual call sign. So I had some interesting things like false positives happening of when a repeater IDs with the time and it says is and then the time, so like is 2 p.m. That is a call sign. It is a real call sign. So it thinks it heard a call sign, even though it technically did, but it wasn't the call sign said. I don't have a metric on that. I do have kind of a general idea about how many call signs I miss versus the ones I've captured, but I don't have a direct metric or stat on how many call signs have been falsely put in the database and how many call signs have been straight up just missed and not heard. It is hard to track, but that's exactly the reason why when I store the transcripts, I store the raw transcript. So I can rerun it through processors and filters later to try to see what the difference is and compare and contrast the difference. Any more questions? I'll swap you.
Okay, you got to be smarter than the mic, I think is the first rule. I'm JR, N7JRJ. A couple questions. Is this an open source project or are you thinking about open sourcing this? Because it feels like multiple contributors could really accelerate some of the things that you're trying to accomplish here.
Yes, this is absolutely 100% open source. Every part of it is open, from the API side of it to the backend side of it. It's on GitHub. Like if you go to KK7NQN.net, everything you see there is public. The website display, how I process it for the website, the actual database, the actual code of every step of it being a separate module is all there, open source, on GitHub. And I fully encourage anyone and everyone to either contribute directly to the project, make their own fork of it, or continue it in some way, shape, or form. Because it benefits everyone when you do that.
Hello. Okay.
There we go.
Yeah, very, very interesting. Two things. Well, the bogus call sign issue, that is a real challenge, isn't it? With Whisper, with WSJTX, they do caching of call signs, and there's predictive algorithm. It's pretty optimistic, and if it gets a wrong call sign, it stays in the database until you flush the cache, and it can cause real problems. But My real question is, I'm curious about the back end. It sounds like it'd be you could somewhat easily take your data and put it in like an online forum format, which would, make it easy to, based on topics, you could sort it by topics or by the person's, who's talking. Just how do you plan to make this easily searchable and accessible by the interested people? Yeah, we could use AI if it goes in there, but is there a more formal format such as a groups.io type of chat forum that you are doing or can see being used for this?
I mean, there's many ways that it can be, and that's actually a part of why the API is there, so the data is directly accessible. And the API has some search functions. The problem I run into now, though, is that I personally am running out of ideas of how it can be used, which is why I open it and modularize it so other people can directly contribute. And I really, really encourage the community's feedback and input of what we should do, where it should be taken, all of that. Like I said, Steve actually prompted the idea of the keyword notification and stuff like that. And for right now, a little bit of back end. Right now it stores everything in the SQL data. It's a MySQL database. It stores everything in. You've got the text of the transcript, the text of the call sign, and the timestamp. And it also has an indicator, one or zero, if that call sign associated with that transcription has been QRZ verified, whether QRZ has said that is a call sign. And then there's a separate data set that it keeps where it's the association between call sign and transcription. And that is very rough, but it's starting. And how I do that right now is it's per push to talk click. So since I'm using a full duplex repeater, when somebody talks, there's a push to talk trigger. And that trigger is what breaks the transcript now. And in most cases, I can assume that push to talk session is one person talking. So if I pull a call sign out of that, it's probably that call sign that said it. It's not perfect, but it's the way I've figured out how to do it yet.
Next question.
Yeah, Craig, N7RWB again. So just throwing out an idea, there's various kinds of nets that occur. There's kind of people just get on and do some informal rag chewing. Then there's more organized nets with a check-in. So adding another layer of analysis to say, oh, I think this is a check-in happening. And then call signs that you detect during that, maybe tag them in a different way than just a call sign just thrown out during the discussion in general. Like I might mention some other person's call sign who's not even on the net, but during a check-in, that person's really probably there. So if you could segment different portions of the conversations you're analyzing, that might add some more data.
Yeah, so that's something I've started doing with the context side of it. How I said it recognizes when it's in a net. It looks for that pattern. So once it's detected that a net has started, when it is looking for call signs, it has a confidence score on call sign that's pulled. And part of that confidence score is one, is that call, have we heard that call sign before? Is it in the database? And two, if we think we're in a net, have we heard that call sign before in this net? And once that confidence score gets high enough with QRZ validation, is when it goes into the database to help try to filter out false positives, stuff like that. And in my net control or net report tab that I've been working on, that is something I want to incorporate is direct check-ins versus what their actual report was. I would like to separate that. I just haven't figured out how to yet. Anyone else?
Well, we're gonna have to cut it short here. Tina reminded me of a couple of points. I was really impressed that this is a bad idea. I was really impressed that you were able to run this on low-end hardware and to my concern that it was a cloud-based system, you assured me that the basic mechanisms were able to run offline, that you were not wholly dependent on cloud services, which was really impressive, especially that you can run it on Raspberry Pi. And to the audience, again, Zero Retries was almost a happy accident of how it evolved. And this was one of those amazing connections. When Hunter, first contacted me and we created an article out of his interest or wanting to get the idea out. Zero Retries was read by Phil Karn, KA9Q, and who is the author of the KA9Q radio. And Phil said, this sounds like a good idea to run in conjunction with KA9Q radio, which again, so it would take a bit of scaling. It probably wouldn't run on a Raspberry Pi, but all the repeaters all the time being automatically transcribed by Hunter's system, so all of a sudden you have complete situational awareness of what's going on all the repeaters in your area. So awesome. Good job, Hunter.
That is something. K9Q's radio actually does have its own TSN now, and the system, a little bit of back end in depth here. The system's full async. So when something goes slow, it doesn't crash out. So like if you run it on a Raspberry Pi and you feed it 5 minutes of audio, it might take an hour to get the transcript back, but it will continue to run. It is fully async. It doesn't care if something fails or runs slow.